Hello dear students, in this video I'll continue solving the sample paper for CBSE Class 12 Applied Mathematics for the academic session 2023-24. In my previous video I have solved the questions from section A of the sample paper. In this video we'll see the questions from sections B and C. So here in section B all questions are compulsory. In case of internal choice, attempt any one question only. All questions in section B consist of 2 marks. The 21st question, at what rate of interest will the present value of perpetuity of rupees 1500 payable at the end of every 6 months be rupees 20,000? In this question, the present value of perpetuity is given, it is rupees 20,000. We have to find the rate of interest at which the present value of perpetuity of rupees 1500. So this is the periodic payment payable at the end of every 6 months. So the number of times compounding is done per year is 2. We have to find the rate of interest R. Let the rate of interest be R% per annum. So here first let us write what is given. Here the present value of perpetuity P, it is given as rupees 20,000, and then the periodic payment R, it is given as rupees 1500. We know that the present value of perpetuity is R by I. I is the number of conversion periods per year. So here it is done every 6 months. So I is, we do not know what is the rate of interest. So it is R by 200. We know that the present value of perpetuity is given by the formula P is equal to R by I. Here since we have to find R, let us write this as I equal to R by P. So this R is 1500 upon 20,000. So this implies R by 200 equal to 1500 upon 20,000. So if we simplify this, we get R as 15%. This implies R is equal to 15%. So here writing what is given and the formula carries 1 mark. Substituting the values and finding the value of R carries 1 mark. So a total of 2 marks for this question. Moving on to the next question. This is a question from matrices and determinants. If A is a square matrix, this matrix 2 minus 2 minus 2, 2 such that A square equal to PA, then find the value of P. So here it is given A square is equal to PA. We have to find the value of P. So first let us find A square. So here given A is this 2 by 2 matrix. 2 minus 2 minus 2. A square, it is nothing but it is A into A. So this is 2 minus 2 minus 2 2 into 2 minus 2 minus 2. So let us multiply these two matrices. First row, first column, 2 into 2, 4 plus minus 2 into minus 2 is again plus 4. So 4 plus 4 is 8. So the first element is 8. Then the second element in the first row, it is 2 into minus 2 minus 4, then plus minus 2 into 2 minus 4. So it is minus 4 which is minus 8. Then minus 2 into 2 minus 4, minus 2 into 2 minus 4. Here also minus 8. And then minus 2 into minus 2 is 4 plus 2 into 2, 4. 4 plus 4 is 8. So this is the matrix A square. A square is this matrix. Now it is given A square is equal to P into A. So this implies 8 minus 8 minus 8, 8 equal to P into the matrix A. Matrix A is here. 2 minus 2 minus 2, or this is 2P minus 2P minus 2P, 2P. So we can compare these two matrices. So on comparing we get 2P is equal to 8 or P is equal to 4. So this is the value of P. The value of P is 4. So here finding the value of matrix A square, it carries 1 mark. Then the remaining steps and finding the value of P carries 1 mark. A total of 2 marks for this question. Now we have the R part of the same question. Here it is given if 0, A3, 2, B minus 1, C 1, 0 is a skew symmetric matrix, then find the value of A plus B plus C. So here let us take this matrix as A, and it is given this matrix is a skew symmetric matrix. After using this condition, let us find A, B and C, and then we can find the value of A plus B plus C. So let us take let A equal to the given matrix. Here it is given A is skew symmetric. Given A is skew symmetric. So this implies A transpose, it is equal to negative A. A transpose is nothing but the rows become the columns. So first row become the first column, second row the second column, and third row the third column. This is equal to minus A. A is this matrix. 0, A3, 2B minus 1, C1, 0. Now we can compare the elements and find the values of A, B and C. On comparing, here we get A is equal to minus 2. Here it is minus of this matrix. So A equal to minus 2. And then we know that in the skew symmetric matrix, all the diagonal elements are 0. Even otherwise, here B is equal to minus B. B equal to minus B. So if we transpose minus B to the other side, we get B plus B, which is 2B. 2B equal to 0 or B equal to 0. And next here if we consider C, C is equal to 3. C equal to, C equal to minus 3. There is minus sign outside. C equal to minus 3. We have to find the value of A plus B plus C. So A plus B plus C is equal to minus 2 plus 0 minus 3, which is minus 5. So the sum of A, B and C, it is equal to minus 5. So here using what is given, that is this matrix is a skew symmetric matrix, writing this step carries half mark. Then comparing the two matrices and finding the values of A, B and C carries 1 marks. And finally finding the value of A plus B plus C carries half mark. So a total of 2 marks for this question. Moving on to the next question. A cooperative society of farmers has 10 hectares of land to grow 2 crops A and B. To control weeds, pesticides has to be used for crops A and B at the rate of 30 grams per hectare and 50 grams per hectare respectively. Further, not more than 750 grams of pesticides should be used. The profit from crops A and B per hectare are estimated as rupees 8,000 and rupees 9,500. Formulate the above problem as LPP in order to allocate land to each crop for maximum total profit. So here the total area of land available for the two crops A and B, it is 10 hectares, and then the pesticides that should be used for crops A and B are at the rate of 30 grams per hectare for crop A and 15 grams per hectare for crop B. Then there is one more constraint, that is not more than 750 grams of pesticides should be used. Next we have the constraint with respect to the area available to grow the crops. So the total area available is only 10 hectares. And then the profit from crops A and B per hectare, it is estimated as rupees 8,000 and 9,500. So we have to formulate this LPP to maximize total profit. So let us take, let X hectares and Y hectares of land be allocated to crop A and crop B respectively. So for crop A we allocate X hectares and for crop B we allocate Y hectares. Here it is given profit for crop A per hectare is rupees 8,000 and profit for crop B per hectare it is rupees 9,500. So the objective function is maximize z is equal to 8000x plus 9500y subject to the constraints. The first constraint is with respect to the land available. So, a total of 10 hectares of land is only available for the two crops A and B. So, x plus y should be less than or equal to 10. X plus y less than or equal to 10. This is the first constraint. Then the second constraint is the constraint with respect to the amount of pesticides that should be used. So, for crop A and for crop B, 30 grams per hectare should be used for crop A and 15 grams per hectare should be used for crop B. And then the total pesticide should not be more than 750 grams. This is in grams. The next constraint is 30x plus 15y less than or equal to 750. Or if we simplify, when we divide the whole thing by 15, 2x plus y less than or equal to 50. And next we have the non-negativity constraints, x greater than or equal to 0 and y greater than or equal to 0. So, this is the formulation of this given linear programming problem. So, here writing the objective function carries half mark and writing the constraints carries 1.5 marks. A total of 2 marks for this question. Moving on to the next question. A man rows 15 km upstream and 25 km downstream each in 5 hours. Find the speed of the stream. So, here the distance travelled upstream is 15 km in 5 hours and distance travelled downstream is 25 km in 5 hours. We have to find the speed of the stream. So, let the speed of the boat and speed of the stream be x km per hour and y km per hour respectively. Now, the distance travelled upstream, it is 15 km. Now, we know that distance is equal to speed into time. So, here the upstream speed, it is given by x minus y and then the time taken is given as 5 hours into 5. This is equal to 15. So, if we simplify this, we get x minus y equal to 3. Let us take this as 1. And then the distance travelled downstream, it is given as 25 km. Again, distance is equal to speed into time. The downstream speed is x plus y and then the time taken is again 5 hours. So, x plus y into 5 equal to 25, or we have x plus y equal to 25 by 5, which is 5. Now, let us solve 1 and 2. Solving 1 and 2, implies when we add these two equations, we get 2x is equal to 8 or x is equal to 4. If x is 4, from 1, y will be 1. Y is equal to 1. So, here we have taken x as the speed of the boat and y as the speed of the stream. We got y is equal to 1. So, speed of the stream is 1 km per hour. This is speed of the stream. So, here writing this carries half mark, then writing the next equation carries half mark, then solving and finding the values of x and y carries half mark and the final answer carries half mark. So, a total of 2 marks for this question. They are part of the same question. A can run 40 meters while B runs 50 meters in the same time. In a 1000-meter race, find by how much distance B beats A. So, here when A runs 40 meters, B can run 50 meters. We have to find in 1000-meter race how much distance B beats A. So, B is able to run faster than A. As a result, B will beat A. So, in the same time, When B runs 50 meters, A runs 40 meters. This is given in the question. So when B runs 1 meter, A runs 40 by 50, which is equal to 4 by 5 meter. So in a 1000-meter race, when B runs 1000 meters, A runs 4 by 5 into 1000, which is 800 meter. So hence we can see that B beats A by 1000 minus 800 equal to 200 meter. Here each step carries half mark, so a total of 2 marks for this question. Moving on to the next question. A machine produces washers of thickness 0.5 millimeter. To determine whether the machine is in proper working order, a sample of 10 washers is chosen, for which the mean thickness is 0.53 millimeter and standard deviation is 0.03 millimeter. Test the hypothesis at 5% level of significance that the machine is working in proper order. Here it is given the table value of T for 5% level of significance and 9 degrees of freedom is 2.262. So here we are given a machine produces washers of thickness 0.5 millimeter. So for the machine to work properly, it has to produce washers of thickness 0.5 millimeter. So this is the population mean mu. This is mu. To determine whether the machine is working in proper order, a sample of 10 washers is chosen. So here the sample size is 10. This is n, for which the mean thickness is 0.53 millimeter. So this is the sample mean, which is x bar. And the standard deviation is 0.03 millimeter. So this is the sample standard deviation, which is small s. Now here we have to test the hypothesis at 5% level of significance. So for this we can use one sample t-test. So for that first we have to write the null hypothesis H0 and the alternate hypothesis H1. Define null hypothesis H0 and alternate hypothesis H1 as follows. H0 will be, we assume that the machine is working in proper order. If that is the case, then mu should be equal to 0.5 millimeter. 0.50 millimeter. The alternate hypothesis H1 is, it does not produce washers of thickness 0.5 millimeter. So it is mu not equal to 0.5 millimeter. Since we have the alternate hypothesis as mu not equal to 0.5 millimeter, this is a two-tailed test. So here a two-tailed test is applied under hypothesis H0 and we have T equal to x bar minus mu upon s by root of n minus 1. Since here we are using the sample standard deviation, we have to use root of n minus 1. So this is x bar minus mu upon s into root of n minus 1. So x bar, it is 0.53 millimeter, mu is 0.5 millimeter upon s is 0.03 into root of 10 minus 1. So this is 0.03 upon 0.03 into root of 10 minus 1 is root 9. So this is 3. Therefore, T equal to 3. So this is the calculated value of T. Now the table value of T is 2.262. Since the calculated value of T is 3, it is more than the table value. We can reject H0. So as a result, if we reject H0, we have to accept H1 and we can conclude that the machine is not working in proper order. So if we reject H0, then the meaning is that the machine is not producing washers of this much thickness, 0.5 millimeter. As a result, the machine is not working in proper order. So let us write the conclusion and the result. Since the calculated value of T calculated, it is equal to 3, is greater than the table value of T, which is 2.262 for 10 minus 1 equal to 9 degrees of freedom. So here the degrees of freedom is given by n minus 1. Here n is 10. So it is 9 degrees of freedom. The null hypothesis H0 can be rejected, and hence we conclude that the machine is not working properly. So here finding the value of T, writing the null and alternate hypothesis, and then writing the formula for T and finding the value of T, all these carries 1 mark, and then writing the conclusion carries 1 mark. Total of 2 marks for this question. Moving on to the next question. Next we have the next section, section C. Here each question carries 3 marks. All questions are compulsory. In case of internal choice, attempt any one question only. So here we have to find integral x cube upon x plus 2 dx. So here we can see that the degree of numerator is more than the degree of denominator. So let us do long division and then simplify. So when we divide x cube by x plus 2, first we have x square. X square into x plus 2 will be x cube plus 2x square. Let us subtract. So this will be 0 minus 2x square. Then minus 2x. So minus 2x into x is minus 2x square. Then minus 2x into 2 is minus 4x. So when we subtract, this becomes plus, this becomes plus. So it is 0 plus 4x. Next we have quotient is plus 4. So it will be 4x plus 8. This is 4x plus 8. So when we subtract, this becomes minus 8. So this is the remainder. So first let us write the given integral as I. Let I equal to integral x cube upon x plus 2 into dx. So this is equal to quotient plus remainder upon divisor. So this is equal to integral x square minus 2x plus 4 minus 8 upon x plus 2 dx. So this is integral x square dx is x cube by 3. Then minus 2 integral x dx is minus 2 into x square by 2 plus 4 integral dx is plus 4x. Then minus 8 integral dx by x plus 2 is minus 8 log mod x plus 2 plus the constant of integration c. So here this 2 and this 2 will get cancelled. So we get the final answer as x cube by 3 minus x square plus 4x minus 8 log mod x plus 2 plus c. So this is the given integral. So here performing long division and getting this step, it carries 2 marks. Then the remaining steps and the final answer carries 1 mark. So a total of 3 marks for this question. Moving on to the next question. Find integral x square plus 1 log x dx. So here this we can integrate using integration by parts. So using the property I let, we can determine which can be the first function and which can be the second function. So let us take let I equal to the given integral. Let I equal to x square plus 1 into log x dx. So here L stands for logarithmic function and A stands for algebraic function. Since L comes first, let us take log x as the first function and x square plus 1 is an algebraic function. So this is the second function. Now integrating by parts. That is, we have to use integral u dv equal to uv minus integral v du. So this becomes the first function, which is log x, into integral of the second function. Then minus derivative of the first function into integral of the second function. So this is how we can integrate by parts. So this becomes log x into integral x square is x cube by 3 plus integral dx is x minus integral, here derivative of log x is 1 by x into integral x square plus 1 dx is x cube by 3 plus x dx. So all these are rough. So the given integral is log x into x cube by 3 plus x minus integral. Here we can divide each term by x. So here x cube by x becomes x square by 3 is already there plus x by x becomes 1 plus 1 dx. So this is log x into x cube by 3 plus x minus integral x square dx is x cube by 3, that is already 1 3. So it is x cube by 3 into 3, which is 9. Then minus integral dx is x plus the constant of integration c. So this is the integral of x square plus 1 log x dx. So here integrating by parts and writing this step carries 2 marks. The remaining steps and the final answer carries 1 mark. A total of 3 marks for this question. Moving on to the next question. Cost of two toys A and B are rupees 50 and rupees 75. On a particular Sunday, shopkeeper P sells 7 toys of type A and 10 toys of type B, whereas shopkeeper Q sells 8 toys of type A and 6 toys of type B. Find the income of both shopkeepers using matrix algebra. So here we have the two toys whose cost is given as 50 rupees and 75 rupees, and then on a given Sunday, shopkeeper P sells 7 toys of A and 10 toys of B, and Q sells 8 toys of A and 6 toys of B. So we have to use matrix multiplication to find the income of both the shopkeepers. So first let us write the sales matrix. The sales matrix, yes, it is given by, so here if we take the toys in the column, toy A and toy B. First, the first row is for shopkeeper A. Shopkeeper A sells 7 toys of toy A and 10 toys of type B. And shopkeeper P. And shopkeeper Q sells 8 toys of type A and 6 toys of type B. And next we have the cost matrix, which is given by 50 and 75. 50 and 75 for A and B. This is for A and this is for. So the income is given by, let me write it here. Income is given by S into C, which is 7, 10, 8, 6 into 50, 75. So now let us multiply these two matrices. First row, first column, it is 350 plus 750. Then second row, first column, it is 400 plus 450. First row corresponds to shopkeeper P and second row corresponds to shopkeeper Q. So this when we add, we get 1100 and 850. Therefore, income for shopkeeper P is 1100. Income for shopkeeper P is rupees 1100 and for shopkeeper Q is rupees 850. So this is how we use the matrix algebra or the matrix multiplication to find the income of the two shopkeepers. So here writing the sales matrix and the cost matrix carries 1 mark, and then using matrix algebra finding the final answer carries 2 marks. Moving on to the next question. Find the intervals in which the function f of x is equal to 2x cubed minus 9x square plus 12x minus 5 is increasing or decreasing. So this is the given function. So first we have to find the critical points, and then we have to find the intervals in which the function is increasing or decreasing. So given f of x is equal to this given function 2x cubed minus 9x square plus 12x minus 5. So to find the critical points, first let us find f dash of x. F dash of x is 6x square minus 18x plus 12, or this is equal to 6 into x square minus 3x plus 2. Or if we factorize this, it is 6 into x minus 1 into x minus 2. Now at the critical points, we know that f dash of x is equal to 0. This implies 6 into x minus 1 into x minus 2 equal to 0, or 6 is not equal to 0. So x minus 1 equal to 0 or x minus 2 equal to 0. So we get x is equal to 1 and x is equal to 2. These are the critical points. Now let us draw the number line. So here the entire number line is divided into the intervals minus infinity to 1, then 1 to 2, and then 2 to infinity. So here starting from the right, we know that f dash of x is positive, then negative, then positive. So let us draw the table and see the intervals. Here we have to find the intervals in which this function is increasing or decreasing. As a result, the interval consists of open minus infinity closed 1, then closed 1 comma 2, then closed to open infinity. In this interval from minus infinity to 1, the sign of f dash of x is positive, so it is greater than 0. If it is greater than 0, then the function f is increasing. It is greater than or equal to 0. And next in the interval 1 comma 2, we can see that the sign of f dash of x is less than or equal to 0. So it is decreasing. And next we have the interval 2 to infinity. Here again it is positive. So it is again increasing. So the intervals in which f of x is increasing is open minus infinity close to 1 union closed to open infinity, and it is decreasing in the closed interval 1 comma 2. So these are the intervals in which it is increasing or decreasing. So here finding f dash of x and factorizing up to this carries 1 mark. Finding the critical points x is equal to 1 and x is equal to 2, it carries half marks. And then finding the intervals carries half mark. And then the interval in which where it is increasing and decreasing, this carries 1 mark. A total of 3 marks for this question. Moving on to the next question. The demand and supply functions under pure market competition are demand function is given by 16 minus x square and supply function is given by 2x square plus 4 respectively. Here P is the price and X is the quantity of the commodity. Using integrals, we have to find the consumer surplus. So here it is given, it is under pure market competition. Under pure market competition, the quantity demanded is equal to the quantity supplied, or PD is equal to PS. So under pure competition, PD equal to PS. So from this we can find x. 16 minus x square equal to 2x square plus 4. Or if we transpose 4 to the other side, 16 minus 4 is 12 equal to 2x square plus x square, which is 3x square. Or we get x square equal to 4, x is equal to plus or minus. Here, since x is the quantity of the commodity, x cannot be negative. Therefore, x naught. This is 2. So the equilibrium quantity is 2. So when x naught is 2, P naught we can calculate from this. P naught is equal to 16 minus 2 square, 16 minus 4, which is 12. So now we know x naught and P naught. Using this, we can find the consumer surplus. So the consumer surplus is given by integral 0 to x naught demand function dx minus P naught x naught. So this is integral 0 to 2. Demand function is 16 minus x square. 16 minus x square dx minus P naught x naught is 12 into. So this when we integrate, we get 16x minus x cube by 3 with the limits 0 to 2 minus 24. So when we substitute the upper limit, it is 16 into 2 minus 2 cube by 3 minus lower limit is 0 minus 24. So this is 32 minus 8 by 3 minus 24, or it is 8 minus 8 by 3, which is 24 minus 8 by 3, 16 by 3 units. So this is the consumer surplus. So the consumer surplus is 16 by 3 units. So here finding the value of Vx, it carries 1 mark. Then finding the value of the equilibrium price carries half mark. Writing the formula for consumer surplus carries half mark. And the remaining steps and final answer carries 1 mark. Total of 3 marks for this question. Now moving on to the R part of the same question. The demand and supply functions under the pure market competition are: demand function is given by 56 minus x square and supply function is given by 8 plus x squared by 3 respectively, where P is the price and x is the quantity of the commodity. Using integrals, we have to find producer surplus. So here the demand function and the supply function is given, and it is given these are under pure market competition. So under pure market competition, PD is equal to PS. Using that, we can find X, and then we can find that is X naught, that is the equilibrium quantity, and then we can find P naught, which is the equilibrium price, and with the help of these, we can find the producer surplus. Now we know that under pure market competition, the demand function and supply function, both these are equal. PD equal to PS. So this implies 56 minus x square equal to 8 plus x square by 3. So from this we get 56 minus 8 equal to x square by 3 plus x square, or 48 is equal to 4x square by 3. Now this when we simplify, we get x square as equal to 36. So this means x is equal to plus or minus 6. Now we know that x cannot be negative. Since x can't be negative, x is equal to 6 units. So x naught is 6. When x naught is 6, we can find P naught as 56 minus 6 square. 56 minus 6 square, it is 56 minus 36, which is 20. So this implies P naught is 20. So when x naught is 6, we have got P naught as 20. Now we can find the producer surplus. We know the formula. It is given by producer surplus. It is equal to P naught x naught minus integral 0 to x naught If you are finding producer surplus, we have to take the supply function. PS dx. So P naught we know it is 20, x naught is 6, minus integral 0 to 6. Supply function is 8 plus x squared by 3. 8 plus x squared by 3 dx. So this is 120 minus, when we integrate this, we get 8 integral dx is x, plus 1 by 3 into integral x squared dx is x cubed by 3, plus x cubed by 3 into 3, 9, with the limits 0 to 6. So this is 120 minus, when we substitute the upper limit, it is 8 into 6, 48, or 8 into 6 plus 6 cube by 9 minus lower limit is 0. So this is 120 minus 48 minus 6 cube is 216. 216 divided by 9. So it goes 24. So this is 128 minus 48 minus 24. It is equal to 48. Therefore, producer surplus is equal to 48 units. So this is the answer for producer surplus. So here finding the value of x, it carries 1 mark. Then finding the value of P naught by substituting for x naught, this carries half mark. Formula carries half mark. And then the remaining steps and the final answer carries 1 mark. A total of 3 marks for this question. Moving on to the next question. This is a question from EMI. Mr. Surya borrowed a sum of rupees 5 lakhs with total interest to be paid rupees 2 lakhs flat, and he is paying an EMI of rupees 12,500. Calculate the loan tenure. So here the amount borrowed, it is given, it is rupees 5 lakhs, and then the total interest flat, it is given, it is rupees 2 lakhs, and then the amount of EMI is also given. We have to find the loan tenure. First, let us write what is given here. P is equal to rupees 5 lakhs, that is the principal amount. And then the interest is flat, it is rupees 2 lakhs, and EMI is rupees 12,500. We have to find N. Now we know that the formula for EMI under flat rate system is P plus I upon N. So this, when we substitute all these values, we will get the value of N. So this implies 12,500 equal to 5 lakhs plus 2 lakhs upon N. Or N is equal to, here 5 lakhs plus 2 lakhs is 7 lakhs upon 12,500. So this, let us simplify. So N is 56. Therefore, loan tenure equal to 56 months. Here writing the formula and writing what is given, all these carries 1.5 marks. Then substituting the values and finding the final answer carries 1.5 marks. A total of 3 marks for this question. Moving on to the next question. Mr. Sharma wants to send his daughter abroad for higher studies after 10 years. He sets up a sinking fund in order to have rupees 5 lakhs after 10 years. How much he should set aside semi-annually into an account paying 5% per annum, compounded annually? Here we can use the value of 1.025 whole raised to 20 as 1.6386. So here we can see that this is a sinking fund question. They have given it in the question itself. Mr. Sharma, he wants to send his daughter for higher studies after 10 years, and the amount required is rupees 5 lakhs. So for this purpose, a sinking fund is set up to have this much amount, rupees 5 lakhs after 10 years. We have to find how much he should set aside semi-annually, where the rate of interest is 5% per annum. That is compounded annually. So let us take, let rupees R be set aside biannually for 10 years in order to have rupees 5 lakhs after 10 years. So here let us write what is given. Here the amount to be accumulated, it is rupees 5 lakhs. And then the number of payments he sets aside semi-annually for 10 years. So n is 10 into 2, which is 20. And then the rate per period I, it is given by 5%, and since it is set aside semi-annually, here we have I as 5% by 2. It is 0.05 by 2, which is 0.025. So this is I. Now we know the formula for sinking fund. A is equal to R into 1 plus I the whole raised to n minus 1 upon I. Here we need to find R. So this implies R is equal to A into I upon 1 plus I the whole raised to n minus 1. So when we substitute all these, we will get the answer. So it is 5 lakhs into 0.025 upon 1 plus I. So it is 1.025. 1 plus 0.025 is 1.025 the whole raised to 20 minus 1. So here 5 lakhs into 0.025 is 500 into 25. So it is 12,500 divided by 1.025 whole raised to 20 is 1.6386. It is given in the question, minus 1. So this is 12,500 divided by 0.6386. So we can either divide this. If it is difficult to divide, we can also use log tables to find the value. So if we use log tables, let us take, let x is equal to 12,500 by 0.6386. So log x will be log of 12,500 minus log of 0.6386. So log 12,500 is 4 point, in log tables we have to see 12 and 5 along the row 12 and column 5 it is 0969 minus, for log 0.6386 it is bar 1 point, we have to look along row 63 then column 8 and then we have to add the mean difference. So it is 8052. Now to subtract this, it is 4.0969 minus of minus 1 then minus 0.8052. So here minus of minus 1 is plus 1. Here 4.0969 plus 1 is 5. So we have to do 5.0969 minus 0.8052. So this we can subtract 4.2917. So this is 4.2917. So x will be anti-log of this. Anti-log of this will be anti-log of 0.2917 into 10 raised to 4. So this is 1.9574 into 10 raised to 4. So if we take the anti-log tables and look along 0.29 row and then 1 along the column and add the mean difference along 7, we will get 1957. So this is 1.9574 into 10 raised to 4. So here the answer for this is 19574 or it is 19,574. So all these can be done in the rough. So the amount to be set aside at the end of every 6 months, it is rupees 19,574. This much amount can be set aside. Here, this should be as 5% per annum compounded semi-annually. This is semi-annual. Here, writing what is given carries half mark. Then writing the formula, substituting the values and getting the final answer. All these carries 2.5 marks. A total of 3 marks for this question. I hope this video was useful for you. In my next video, I'll solve the questions from sections D and E of the sample paper for applied mathematics. Thank you for watching.